All right. The first method to make an ether was found by Alexander Williamson, a British chemist. He demonstrated this reaction in 1850, so it's way back then. Let's see what Williamson did. So start with an alcohol, adding sodium hydroxide, and then add an alkyl halide. All right. There will be an SN2 reaction here. This alkyl halide has got to be either methyl or primary alkyl halide. Secondary is less effective because it competes with elimination, and the tertiary stop or block an SN2 backside attack, if you remember. Okay. I'll give you some example. Let's take a look at the mechanism. So we have an ethanol, add sodium hydroxide, and benzyl bromide. So we get the benzyl group, so phenyl ring and one carbon. That's a benzyl group. So we got a benzyl group on the oxygen right there. Make it ether. All right, here's the reason why we add sodium hydroxide. Sodium hydroxide acts as a base. This guy never been in a nucleophile, right? It's too small. It's not polarized. So it can only attack another hydrogen. So we add sodium hydroxide to deprotonate the alcohol, make it more nucleophilic. Okay, but alcohol by itself it's a poor nucleophile basically. So we make it a better nucleophile by adding a base, abstract proton. We get a negative charge on oxygen. This is a strong nucleophile. All right. After this, so we add a primary, or this is the reason why we either add methyl or primary alkyl halide. Secondary and then tertiary doesn't do well right here because this is SN2 reaction. Okay, and ta-da, we get an ether. All right. So if we go backward, all right. So I try to think backward. So let's say I want to make a third butyl methyl ether, or we call MTBE. We used to use this guy as an additive for gasoline, but because of the concern of groundwater contamination, so we stopped using it. Anyway, so let's say we try to make it using Williamson synthesis. What do we do? Oh, what do you think about the first one here? Is it going to work? You probably say, no, this is tertiary. You cannot do backside attack. Yeah, so you can't do an SN2 on tertiary, right? Alkyl halide. But we can do this. Switch these two. So instead of using third butyl bromide as an alkyl halide, use it, the one who attack other people. So use it as an alcohol. Right, and the other one, so we have methanol right here. So this is primary. Actually, this is good for an SN2 reaction. So make it an alkyl halide. So switch position here. Right, sodium hydroxide will deprotonate that oxygen, become better nucleophile, and then attack the methyl bromide. Okay, so this one much better. Right, so tertiary doesn't work for an SN2 reaction. I'm sure you know that. All right, let's say analyze real quick. So look at the structure. How do we make this? Should be able to think in two ways. One way, let's say if I cut that bond, you should. This guy can be made from a phenoxide ion. So this is phenol, right? Used to be phenol. This is phenoxide. Attack the alkyl halide. This is primary alkyl halide. So this works, right? So we're gonna start with a phenol. Add sodium hydroxide to make a phenoxide ion, and then add ethyl bromide. You get the product there. Let's try another way. All right, so cut this bond. In this case, you're going to have an ethanol attack the benzene ring. Look something like that. Is this going to work? No, you cannot attack on the benzene ring. If you remember, so a high electron density inside the ring. The backside attack have to go, like the nucleophile have to go inside the ring and attack right there. So that's not going to be possible. Too high electron density, they repel. Okay. All right. Benzene doesn't work either. So tertiary doesn't work. Benzene doesn't work. Right. So in this case, so when we want to do synthesis using Williamson synthesis, we look for primary alkyl halide. Right. So we see the primary position right here. So we know that this should be an alkyl halide. So we have ethyl bromide, and the other part on the left side, that's the nucleophile. Okay. Same thing here. So we want to make this guy. We have vinyl, allyl, vinyl ether. Right. So you should be able to see that. Okay, that position right there, that's primary position. It's better to have this guy on the right here to make an alkyl halide. Right, and then we have a vinyl attack. Right, this is vinyl alcohol attack right there. Better than we have a vinyl alkyl halide, so the alcohol cannot attack that. Right, too high electron density from the pi bond. Okay, so benzene, vinyl halide, tertiary alkyl halide doesn't work. Okay, so avoid those. All right, one more time. So how do we synthesize this? Well, so you can see, let's say if I cut this bond right here, so it looks like this oxygen attacked that carbon. Right? This oxygen attacked this carbon and form bond. So you can make it right there. In the same molecule, this is intramolecular Williamson synthesis. Okay, so basically, so 1, 2, 3, 4, so 4 carbon, 1, 2, 3, 4, and that. Just add a sodium hydroxide. This guy gonna get deprotonated, and then they're gonna go attack the bromide and form the ring. This is THF, tetrahydrofuran. Okay, all right, let's go. So that's Williamson ether synthesis. The first way, first method to make an ether. Let's take a look at the new one, another one.